Hello guys and welcome to Edushaman YouTube channel again. So we might have heard of this term digital everywhere around us, but what does this term digital even mean? So digital, if I had to put it in just a single word, it means storage. Life as it happens around us happens in analog. If you ask me to reproduce what's happening between us right now, like a communication between us, a conversation, can I reproduce it in real life terms? No, because the time has already passed. But I can always capture it. And this capturing is what we call as digital. We can store what has happened in life in the form of zeros and ones, that is bits. We capture what happens in analog form into a digital form. So now that we know that digital means storage, we'll figure out what bits actually mean. So bit is nothing but the presence of something or the absence of something. Here we have two integers, two digits, 0 and 1. 0 indicates the absence of something and 1 indicates the presence. Supposingly, I am talking to you and in this conversation, this is my voice. Now, how can I store it? So what I would do instead is divide this whole voice of mine, say it has taken 2 seconds, I have spoken in 2 seconds, okay? I'll store it to ideally infinite parts, but we can't do it in reality. So what we will do, remember that there is always a loss of signal. We cannot reproduce what has happened fully, but we can reproduce it to the maximum extent with minimum losses. So if I take, say, 1000 parts of this signal, I divide this entire graph by 1000, okay? And I find a point, see 2 seconds by 1000, say. So I get some 0.0002 in time space. So I take these small points over here, here, and I measure them. So say this is 0 and this is, say, 500. Okay, and say this is 33. This is, say, 56. This is, say, 67. So I know that at this particular point of time, say 0.02 seconds, my voice is 33. At say this is 0.04 seconds, my voice is 56. So now I will have to store these numbers because I can't store the waveform, right? I can't store anything analog. So what I will do is I will store all these small points. Now let's see how we can store 33 as. So for those of you who already know this 33, this is in decimal system, right? And bits uses zeros and ones. So 2 to the power 5 gives me 32. And 2 to the power 6 gives me 64. And 33 is between 32 and 64. So I can organize this 33 in terms of ones and zeros, right? That is in terms of bits. 33 can be represented as 1, 0, 0, 0, 0, 1. This is 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Essentially what we are saying is that 33 is 2 to the power 5 plus 2 to the power 0. 1 into 2 to the power 0 plus 1 into 2 to the power 5. But what are these 6 spaces that we have? We have 6 spaces here, right? So these 6 spaces are essentially 6 bits. Here we say there is a presence, and this 0 we are saying there is no presence, no presence, no presence, absence, and there is a presence. So basically we took 6 bits to represent this number 33. So this is how you convert analog waveform into a digital storage mechanism. That is, you need some memory for that. For example, in your Almira shelf, you may be having certain spaces in which you can store your clothes. So either you can store it there or you may not store it there. That is what the information is all about. If is it present or is it not present? So to convert an analog form into a digital form, what do we need? We need memory spaces, which we organize in terms of bits, and 8 bits forms a byte.